Welcome to Chapter 5 in Geometry, Quadrilaterals. So we're going to be dealing with four-sided shapes. Notice the first section we're going to cover today deals with properties of parallelograms. Section 5.1, Properties of Parallelograms. The objective that you're going to learn today is this. After studying this section, you'll be able to apply the definition of a parallelogram and the theorems and properties of a parallelogram. To get started, 1, draw yourself a parallelogram, and then 2, write down as many properties of parallelograms as you can think of. So here's a good opener to see what you currently know before we start talking about the information. Parallelogram. Notice the symbol for a parallelogram you can use looks sort of like a parallelogram. The definition is it's a quadrilateral with both pairs of opposite sides parallel. So if you look to the right, to be a parallelogram, the top and the bottom have to be parallel, and then the left and the right sides are also going to be parallel. So definition tells you opposite sides are parallel to each other. Let's look at some other properties of parallelograms. Our first theorem, Theorem 5.1, says opposite sides of a parallelogram are congruent. So if we know that something's a parallelogram because they tell us the opposite sides are parallel, we also get some other information as well. Besides being parallel, we also know that the opposite sides happen to be congruent to one another. Let's look at another piece of information. Theorem 5.2 tells us that opposite angles of a parallelogram are congruent. So if you know that something is a parallelogram, again, because the opposite sides are parallel to each other, not only do we know that the opposite sides are congruent, but we also know that the opposite angles are congruent. So the angle down here in the bottom left is the same size as the angle up here in the top right. Likewise, the other two opposite angles are also going to be congruent to one another. Let's look at another property. The next property tells us that the diagonals of a parallelogram bisect each other. So if we start off knowing that something is in fact a parallelogram, so meaning we know the opposite sides are parallel, if we happen to bisect or draw the diagonals, they're going to bisect each other. So if I draw the diagonal from vertex to vertex and vertex to vertex, it just so happens that they end up bisecting each other. So it means this diagonal got bisected and it's cut into equal sized pieces, and the other diagonal got bisected and it also got cut into equal sized pieces. Let's look at how we can use this. So a couple questions. Classify each statement as true or false. So try to answer these before you hear me tell you what the answer is. First one, every parallelogram is a quadrilateral. So it's pretty much saying, if something's a parallelogram, does it have to have four sides? And we know the answer is true. Let's look at the next question. Every quadrilateral is a parallelogram. So this one is saying, if something has four sides, does it have to be a parallelogram? And we know the answer is going to be false. And it's easy to show an example. Just draw, for example, a shape that looks like that. There's four sides, but it's definitely not a parallelogram. Next question. All angles of a parallelogram are congruent. False. What we had learned in one of the previous statements wasn't that all of them are congruent, but that opposite ones are. So imagine if you had a parallelogram. We don't know that all four angles are the same. We only know that the opposite angles are congruent. Right. All sides of a parallelogram are congruent. Here's another one that is false. I know that opposite sides of a parallelogram are congruent, but I don't know that all four of them are. And even by looking at the example here, it definitely looks like the top and the bottom are longer than the left and the right sides. All right, number 5. In parallelogram RSTU, segments RS would be parallel to segment TU. The easiest way to do this one is draw yourself a picture. So it doesn't have to be fancy, but draw yourself a parallelogram. And when it's called RSTU, start at any vertex and start going clockwise or counterclockwise, labeling R, S, T, and U. And now check. Does it look like you have the appropriate segments? So is segment RS parallel to segment TU? And they are opposite sides in the parallelogram, so they should actually be congruent, so that would be true. Next question. In triangle ABCD, if the measure of angle A is 50, then the measure of angle C equals 130. Okay. Here's another problem where drawing a picture is going to be a big help. So start by drawing yourself a parallelogram ABCD, and it doesn't matter where you start labeling, so I'm going to start in the upper left. A, B, C, D. And I'm going to fill in angle A is 50, and angle C, it says, is 130. And is that true or false? And it's going to be false because opposite angles need to be congruent. So they have to be either both be 50 or both be 130. All right. Number 7. We have ourselves another parallelogram, and let's see. Segment XY is congruent to segment WZ. Again, easiest thing to do is draw yourself a picture to try to decide if this is going to be true or false. So I make myself a parallelogram and label it XWYZ. And they're telling us that segment XY is congruent to segment WZ. Well, XY happens to be a diagonal, and WZ happens to be a diagonal. So do you know that the two diagonals are going to be congruent to each other? And we don't. We know the diagonals bisect each other, but we don't know that they're congruent to each other. So this is going to be false. And let's look with one more. In parallelogram ABCD, segment AC and segment BD bisect each other. So drawing another picture so we can see which segments we're looking at. So labeling A, B, C, D, and filling in. So if we're looking at segment AC is a diagonal, and segment BD is a diagonal, and the question is asking if they bisect each other, and they do. We did learn one of the properties was diagonals of a parallelogram do bisect each other, so this would be a true statement. So to recap, the biggest thing we know is opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, and diagonals bisect each other. Looking at the parallelogram to the right, so parallelogram ABCD. Before I even look at any of the questions, if they are telling me it's a parallelogram, the first thing I know is BC parallel to AD, segment AB is going to be parallel to segment DC. All right, now let's see what they have for us. So it says, name all pairs of parallel lines. Well, we pretty much just said that. If it's a parallelogram, I know that BC is going to be parallel to AD. And I know similarly for the left and the right that line AB is going to be parallel to line DC. So opposite sides of a parallelogram are going to be parallel. Number 10, name all pairs of congruent sides. Well, we know opposite sides are congruent. So I know that the top, BC, should be congruent to the opposite side, AD. I know that the left side, segment AB, would then be congruent to its opposite side, which is segment DC. Name all pairs of congruent segments. Now, not only do we get the ones from above in problem number 10, so we get all of those still, because I still get opposite sides parallel, but I also get that the diagonals bisect each other. So if I look in here, I should get that BE and DE are the same, so I can write those down. And the other diagonal would have gotten bisected as well. So I should know that CE and AE are also congruent. So opposite sides parallel, opposite sides congruent, diagonals bisect each other, which also give us some congruent pieces. Let's look at finding some missing values. So it says, using parallelogram RSTU, find the values of X, Y, A, and B. And you can do this in any order you want. So let's just go alphabetical. If I'm looking for A on the bottom, it should be equal to the opposite side, which is 6. Likewise, if I'm trying to find B, it should equal the opposite side, which happens to be 9. All right. Looking at the angles, X and the 80 are opposite angles, so they should be the same. So X is 80. Now, Y, it doesn't tell us how big the opposite angle is, but if you remember back to when you have parallel lines, I know that for parallel lines, that same side interior angles have to add up to 180. So Y plus 80 has to add up to 180 is going to let me know that Y is actually 100. All right, let's look at another one. All right, so here's another parallelogram. So if we start to just look at one piece at a time, I think it makes it a little bit easier. So let's start with A. Going to equal the opposite side, which happens to be 12. B. I know that diagonals bisect each other, so B should be the same as 9. Looking for angle X. All right. I know that angle X would be the same as the opposite angle, which is over here, but I don't know how big that is. So I'm going to do the same thing as the last problem and realize that same side interior angles need to add up to 180. So if I look at the ones that I have, well, down in the bottom left over here, I have a 45 and a 35, which means grand total, angle is 80 degrees. So if that's an 80 degree angle, then the value for X has to be supplementary with that. So X is going to have to be 100. Well, how about angle Y? Angle Y isn't the entire angle, it's only part of it. But since I have parallel lines, I know alternate interior angles are congruent, so the Y is just going to equal 45. Number 14, a proof about parallelograms. Given ABCD is a parallelogram, CEFG is a parallelogram, and we need to prove that angle A is congruent to angle F. So looking where I want to end up, I eventually want to get angle A and angle F being congruent to each other. Well, before I start the proof, let's look at what we do know. I do know some facts about parallelograms. One thing that's important is I know that opposite angles are congruent. So if I look at the large parallelogram ABCD, I notice that angle A is going to be congruent to angle C. Looking at the small parallelogram, I notice in that one that angle F is going to be congruent to angle C. Well, if angle A is congruent to angle C and angle F is congruent to angle C, then angle A should be congruent to angle F. So let's see what it looks like if we actually write out the proof. So we know our first step is always just restating the given information. So let's write down that A, B, C, D is a parallelogram, and we'll use our little symbol for parallelogram. And we'll also need to write down that CEFG is also a parallelogram. And all of that is because it's given. Now we're just going to write down the information that we said in the beginning. I know that angle A and angle C are going to be congruent because they're opposite angles in a parallelogram. So angle A congruent to angle C, and my reason is opposite angles in a parallelogram are congruent. And since angle C and angle F are congruent for the same reason, I can write that down as well. Angle C congruent to angle F. Well, if A is congruent to C and C is congruent to F, angle A congruent to angle F by the transitive property. And we have proved exactly what we were supposed to. Right, wrapping up for today. If you could write down these things, state at least 3 facts about a parallelogram. So any 3 facts that you know. And then after you do that, you're all set.